Hello, everyone. Today we're going to do 1.3 scientific methods. So, objectives, we're going to go over common steps for scientific method, compare types of data and types of variables. And review vocab is systematic approach, which is organized method of solving a problem. These are all the terms. The focus for today is what's killing this plant, or first question is what is wrong with this plant. Now it's brown, has some bites in it. So maybe there's an insect, attacked by an insect. How could you find out what is harming this plant? Now, if you observe it for a while, you might find that maybe it's too much sun, drying out. Maybe there's some specific fungi or insect feeding on it. Soil, maybe. Or maybe the water, lack of water. Scientific method.
Scientific methods. A systematic approach used in scientific study. An organized process used by scientists to do research and to verify the work of others.
Okay. It's an organized process to verify the work of others. So it's a method and steps that were agreed on by scientists and they follow it to verify their work. And starts with observation, hypothesis, and then which is prediction. You make a prediction of what causes the brown spots in a plant, maybe for the focus. And then you observe for a while, you conduct an experiment, and then see if you can come up with data that supports your hypothesis or prediction. Now, if it does, and many scientists agree on it, it becomes scientific law. Now, if it does not agree, then you go back to the drawing board and maybe tweak the hypothesis a little bit. So maybe it's not the sun, maybe there's more involved or more reasons for the brown spots. Okay, next we're comparing and contrasting the qualitative versus quantitative. I think I'll go over on the next slides. The qualitative has to do with observations that describe physical characteristics like color, smell, shape, related to the five senses. Now, the quantitative has to do with numeric observation that describes how much, how fast. So if we're talking about latte, for example, the qualitative will be that maybe it's too strong, too hot. Quantitative will be maybe 12 ounces and the cost of it, which is maybe $4 or so. If we're describing a class, qualitatively will be maybe friendly, noisy. Quantitative would be 40 students, 20% male, 80% females, and or honor roll. Again, hypothesis is actually a tentative explanation, okay, observation. So you observe, try to explain it. So that's a prediction. It's your explanation. You haven't tested it yet. You test it when you actually do the experiment.
Experiment. A set of controlled observations that test a hypothesis.
Okay, so we tested, we tried to come up with evidence that support the hypothesis. Again, if I can predict that the lack of light is affecting the plant, but after observation, it's not just the light, it could be the fertilizers or the soil of the plant as well. So you change the hypothesis a little bit based on the evidence collected. Now we're going to compare independent versus Dependent variable.
Independent variable. In an experiment, the variable that the experimenter plans to change.
Okay, so if we look at x and y, for example, x independent of the y. So as x changes, y changes. So y is dependent on x, on the value of x.
Dependent variable. In an experiment, the variable whose value depends on the independent variable.
Okay, when x is 1, y is 4. When x is 2, y is 8. So there's a formula that depends on x. The value of y depends on the value of x.
Control. In an experiment, the standard that is used for comparison.
Okay, usually the standard is constant and something that's reliable. You compare always your reference point.
Conclusion. A judgment based on the information obtained.
Okay, so hypothesis is proven, is never proven, only supported by evidence. Okay. Now, when
Theory. An explanation supported by many experiments is still subject to new experimental data, can be modified, and is considered valid if it can be used to make predictions that are proven true.
Okay, so we work on experiments and we can modify it.
Scientific law describes a relationship in nature that is supported by many experiments.
Okay, so once you support it with evidence and the scientists agree to it, then it becomes a law and accepted theory. Here's a model for Molina and Rowlands. They try to explain the ozone depletion of the ozone layer, the CFC's effect on the ozone layer, and their explanation is radiation affects the O3, the CFC by giving off one of the chlorines, and when one of the chlorines is given off, that radical is very reactive, and it breaks down the ozone, which is O3, and oxygen is given off. So that's what caused the ozone depletion. And then that free radical is given off again, and the cycle continues. So many scientists agreed on this. So that the CFC is the cause of one of the causes of ozone depletion. So once it's agreed upon, then it's a theory, and then CFCs are not accepted in the atmosphere. All right, and that's it for this section. We'll see you guys next time. Thank you.